Hello everyone and welcome to the NPTEL course on pharmacognosy and phytochemistry. In this session, we will be studying about a little different types of carbohydrates, and those are soluble and insoluble fibers. So what are soluble and insoluble fibers? Sometimes carbohydrate derivatives such as fructooligosaccharides or galactooligosaccharides or pectins for that matter, whenever they are soaked in water, they form a clear viscous solution. The carbohydrate fibers which are soluble in water but do not degrade are called as soluble fibers. They often end up giving us a very viscous mucilaginous solution like we observed in pectin, agar. So most of your gums and mucilages, when they are hydrated, they form a slug like substance which is viscous, gooey and little difficult to digest though. Such kind of fibers are called as soluble fibers. Now when we go to the second type, that is insoluble fibers, sometimes you see that there are fibers, take for example your husk or your rice bran, or sometimes the polishings or certain vegetable fibers. You must have found out that when you are trying to cut your ginger, there are some fibrous things that tend to protrude out of your ginger. So those fibers, even if you put it in water, will not dissolve. Such kind of fibers are called as insoluble fibers. They are generally cellulosic, or they might comprise of hemicellulose, or sometimes they have lignin deposits, and such fibers are said to be lignified fibers. A good example of a very herbal remedy which is given in cases of constipation is your isabgol husk. Now if you see isabgol husk, you might see a cellulosic matter that's definitely there, and when you put it in water, you will see that this isabgol gradually swells over a period of time, that is, it is mucilaginous. So what we have done is we have just taken a little isabgol husk and we have put it on our slide and stained it with a dye called as ruthenium red. What ruthenium red does is it stains the mucilaginous matter, and as you can see, when your isabgol swells, this is the mucilage that is swollen and that has taken up your ruthenium red dye. So there are numerous mucilage containing drugs, and they form an integral component of your soluble fibers. But apart from that, you have your pectins, you have your gums, which also are soluble fibers. So what is the difference between your soluble and insoluble fibers? Let's understand them clearly. So soluble fibers, as the name indicates, if you steep them in water, hydrate it or warm it in water, they will form a clear gel-like viscous substance. We often refer to a glue-like substance, and these are the attributes of your soluble fibers. Whereas when you take your thread, say for example cellulose, or when you take your ginger shreds, when you are doing your cooking, you will see that these fibers or cellulosic fibers or your coir, coconut coir, you will see that this do not dissolve in water, and then they are called as insoluble fibers. So there are numerous sources of soluble fibers. This include your oats, apples. We saw apples are a source of pectin. Citrus, which are also rich source of pectin. Your barley, legumes, they all contain numerous soluble fiber components. Whereas if you see your husk, brans, grains or stiff vegetables, like your carrots and celery, when you crush them, you see some fibrous string like things coming out. Those are all sources of your insoluble fibers. So sometimes even in your diet, people say, you have to eat fibers. So which fibers are good? This is something we'll see in the next point. So if you see the digestion, now the first part is when you take soluble fibers, they will get into your gut, they will swell. So they will give you a feeling of satiety, that is fullness. and they will slow your digestion. Why? Because it's a very viscous solution that has happened or that has occurred in your stomach. So it slows your digestion. At the same time, it decreases, because it's a viscous solution, nothing can get absorbed very quickly. It forms a barrier like thing and hence controls the absorption of your blood sugar as well as cholesterols and sadly some nutrients also. But on the other side, if you see insoluble fibers, imagine something like a rope or a coir. When you consume it, or a bran or husk, they are not going to swell in your stomach per se. They will remain as such, and what happens is they tend to irritate your gut. Now when they irritate the gut, they do not add bulk, but they increase what is called as the peristaltic movement, and as a result insoluble fibers have a little laxative effect as well. Now in terms of fermentability, soluble fibers, because they are already hydrated, they have imbibed water, the microorganisms can get a very easy access to them and hence they can be fermented. Whereas if you see cellulose or lignified fibers, they are pretty stiff, they are not easily digestible, they mostly come out as such in a very undigested or less digested form. In terms of health benefits, definitely these are the fibers which will help you, the soluble fibers will help you prevent a sugar spike. It will decrease absorption of your lipids and hence they help with your heart conditions, they will help you with your weight management, they will help you with your sugar management. Whereas if you see your insoluble fibers, they are the ones which will be triggering your peristaltic movement and preventing your constipation and thus improve your gut health. So let's take an example of a soluble fiber here, and those are your fructooligosaccharides. So what are fructooligosaccharides? As you can see here, it's a polymer of fructose and that's the reason it's called as fructooligosaccharides. So in this you can say that a particular unit fructose, I'm just putting it here, gets repeated n number of times. Now this n can be multiples. So what happens here is there is a linkage between your carbon 1 of fructose and carbon 2. So this is 1 and this is 2. So there are 1-2 linkages which are occurring. So this fructose goes on polymerizing to give you an oligosaccharide chain. And if you see your food products, if you see your onions, if you see your garlic, blue agave, chicory, which is often added in conjunction with your coffee, asparagus, leeks, or Jerusalem artichokes or bananas for that matter, they are very rich source of fructooligosaccharides which are also soluble fibers. Now let's see what are this as described. This is your carbon number 1, this is your carbon number 2, and the kind of linkage happens here is a beta. So it's a beta 2,1 glycosidic linkages, and this can easily be represented by a formula GFN. Why GFN is most of the fructooligosaccharides have their unit or the end unit as glucose and the remaining units are all your fructose. So you can see, and plus if you add a little n here where n is more number of molecules. Now this n can range somewhere between 2 to 60 and the molecular weight goes really high in certain thousands unit. So if you see them in terms of its utility as sweeteners, they are polysaccharides, so they do not have the ability as a sweetening agent, they are mildly sweet, and that is because they get digested by our enzymes into little small sugars, but they do take time for the process, and that's the reason they are mildly sweet. But in terms of its utility as a soluble fiber, it is of great help to us. So how are these fructooligosaccharides prepared? Now industry, or if you go on the retail or e-commerce sites, because of their utility, we just saw how good your soluble fibers work. Because of their utility in market, you will see numerous brands selling your fructooligosaccharides. So they can be obtained by two ways. First, you can obtain them from plant sources, like we saw a few of them. That is what you're going to take is you're going to take the plant Say for example, you can take your chicory, extract it in the warm water to dissolve the soluble fiber, and then get it to a desired size length by help of an enzyme called as inulase. This short chain compounds, which are then dissolved in water, are filtered and then precipitated with alcohol or any organic solvent which is immiscible in water. So your carbohydrates are not soluble in water, and as a result they will precipitate. The other way which industry does it is using your microbial or especially your fungal cultures. So fructooligosaccharides, you can take it using sucrose as a source, that is a carbohydrate source, and use a culture of Aspergillus niger. Now this Aspergillus niger has an enzyme called fructosyl transferase. So this fructosyl transferase takes the molecule of sucrose, and to that sucrose goes on adding one by one molecule of fructose. So if you see here, if you remember, this was your glucose, this was your fructose. So glucose plus fructose together make your sucrose. So to this sucrose, using fructosyl transferase, you go on adding your fructose subunits, and as a result you are going to get your fructooligosaccharides. So here also in industry they do it, and in this case you get it with much higher purity. This is also precipitated using water miscible organic solvents and graded as per the size. In terms of utility, you can think of all uses of water soluble fibers that can be applied. So it helps in weight management and it reduces the cholesterol level. This has been even tried in experimental animals, and you will see numerous supplements already available in market. It's a low calorie sweetener, but its sweetness ability is half of that of your sugar. Now if you want to prepare something which is fortified or much more nutritious or fiber loaded, definitely fructooligosaccharides have been added, and this has been done in your cold drinks, beverages, bakery products, and even in dairy products. Now consumption of soluble fibers, especially fructooligosaccharides, improves the bowel movements and regularity. Now one more little effect associated with fructooligosaccharides are, these are digested by your gut microbiota, and then it is converted into what is called as short chain fatty acids. Now this short chain fatty acids, if you see the overall pH of your intestine, as you move distally towards the colon, the pH becomes alkaline, and as a result your absorption of minerals do not happen in the colonic area. But because your gut microbiome is consuming fructooligosaccharides and producing short chain fatty acids, these acids make the pH slightly towards a neutral side. So they continue to help in absorption of minerals by creating a little acidic pH, and these short chain fatty acids have also been beneficial in management of colon cancer. It also helps growth of prebiotic microorganisms such as your bifidobacteria, but there are some effects associated with overconsumption of fructooligosaccharides. They might be because of the microbiota digesting them, and this include your diarrhea, gas, bloating, or in some cases abdominal cramps. So we go to the next one, and the next one is an example of an water insoluble fiber, and that's your common cellulose. Now if you see cellulose is a polymer of glucose. We did one more polymer of glucose previously, and that is your starch. Now how does it differ? You can see here it only differs by the nature of linkages, and here you will see your beta linkages. So cellulose is commonly found in the plant family. Commercial cellulose comes from wood and cotton. If you see wood, it is still has your tannins which are brown and lignified components, but if you see cotton, cotton has almost 95 to 97% pure cellulose. So if you want to do or have cellulose of commerce, it's generally obtained from wood or cotton fibers. Now agricultural wastes have also been used to harness cellulose, and this include your rice husk, wheat straw. Apart from that, some microbial sources like Acetobacterium xylinum has also been used or explored for the production of cellulose. Now, why is cellulose important? Let's see the chemistry first. Cellulose is a polymer similar to your starch, so you have all your repetitive glucose units, and this time what happens here is the enzyme. Now what is linking during the biosynthesis? Instead of forming alpha linkages, the enzyme selectively create a beta 1,4 linkages. Now what is the advantage of creating beta 1,4 linkages is you will see that when you consume your starch can be easily digested, but because of alpha amylase. Now we don't have beta amylase which can create a hydrolysis or which can cleave your glucose molecule, and as a result cellulose remains mostly undigested with us. Now as it remains undigested, it becomes what is called as insoluble fibers. So cellulose has, if you see the polymeric region, depending on its arrangement, it has both domains, the crystalline domain and the amorphous domain. Now because of that, it has good stability and rigidity. Imagine your coir fibers, they are very difficult to break, but your starch is very pliable, and if you swell it, it forms a viscous gel. Your cellulose do not. That's the beauty of this beta linkages. They are insoluble in water, even in organic solvents. They are strong and considered to be biodegradable, and that makes it a very good excipient. Now the question comes to your mind, how do you apply this as excipient when it is not going to be soluble in anything? So in order to make it soluble, numerous derivatives of cellulose have been prepared. Now I have just put a simple sugar moiety here, and imagine for your glucose, where this was your H and H out here, I am derivatizing it. So for example, let's take this R. In case of this, if I put it as a CH3, I make it a methyl derivative, I create what is called as methyl cellulose. Same way, if I do a H5, I create what is called as ethyl cellulose. So methyl cellulose and ethyl cellulose have been used as excellent binders, and they have the property to swell and absorb water as opposed to cellulose. Now in addition to that, you have something called as hydroxypropyl cellulose. So this is R, and I am just starting it from here. So let's put this as carbon number 1, carbon number 2, carbon number 3, and let's put a hydroxy here. So hydroxypropyl cellulose, and then here if I put an additional methyl, so I'll get methyl hydroxypropyl cellulose, which is also called as hypromellose. So hydroxypropyl cellulose and hypromellose have been used extensively as film forming agents. So imagine sometimes when you have your dry eyes, a doctor gives you a certain drop, and those are made up of hypromellose. Sometimes you might be consuming what are called as those menthol films. We call it as orally disintegrating films. So they are very good film formers, and once you dissolve them in a particular solvent and dry it, they create a nice soft pliable films. So apart from that, you have acetate derivative. So you have your cellulose acetate. In addition to cellulose acetate, there are cellulose acetate phthalate. Now cellulose acetate phthalate gives a very water resistant acid stable film, and that is used for coating your tablets. So numerous derivatives of cellulose can be prepared. You can even play with the amorphous and crystalline domains of the cellulose. Imagine if you hydrolyze the cellulose, only the amorphous domains, because they are very susceptible, they get hydrolyzed, and the crystalline domain remain. This crystalline domains precipitate to form what is called as microcrystalline cellulose. So you have MCC, which is microcrystalline cellulose, which is used in pharmaceutical industry as a good binding agent and disintegrant. You have nanocellulose, which is used nowadays in drug delivery system. You also have cross-linked cellulose, which is obtained nowadays for creating what is called as bioplastics. So numerous cellulose derivatives have been prepared, but apart from pharmaceutical, if you see your textile industry, imagine your cellulose, you can dissolve it by using alkali. So you convert it into a sodium salt and then treat it with something called as carbon disulfide. Now this sodium or potassium salt, when treated with carbon disulfide, completely dissolves in a media, that is your basic media, and then when you just put this blend through a needle and put it in acidic pH, you get this regenerated cellulose. So your rayon, or what is referred to your viscose, is actually a regenerated cellulose. So this is used to make fabrics, this is used to make papers. So cellulose has a very extensive utility. So if you see in terms of applications, it's used in papers, textiles, especially cellophane to prepare rayon, in pharmaceuticals, binders, fillers, or dusting agents for your gloves. Nowadays, your HPMC, hydroxypropyl methyl cellulose, is also used in creating your vegan capsule shells, which were earlier made up of gelatin. In food industry, it is used as thickener and stabilizer, and nowadays because of nanocellulose, it's also used in nanoplastics, in composites, electronics, and cross-linked cellulose is used to prepare bioplastic. So here's to further reading, and thank you for your attention.